So the product rule for derivatives helps us to find the derivative of a product of two functions. So here we have our two functions, f and g. And this right here means f times g. It does not mean bassoon, for those of you who might know that bassoon is sometimes abbreviated fg. Just thought I'd mention that. So we're going to do some implicit differentiation here. I should make a note first that do not try to take the easy way out and think that this means you just take the derivative of each function and then multiply them together, because that does not work. So we're not going to do that. We're going to see if we can figure out a better way to do this. So I'm going to take y to be fg. And here we have a product. We don't know how to take the derivative of a product. We do know how to take the derivative of a sum. And we can use logarithms to help us turn a product into a sum. Let's see how we can do that. So I'm going to take the natural log on both sides. And on the left side, I'll just have natural log of y. And when you have a product inside of natural log, you can write it as sum of two natural logs. So we'll have natural log of the first factor plus natural log of the second factor. And now we're ready to do our implicit differentiation. So I'll go ahead and take the derivative. Let me use a darker color here. The derivative with respect to x on both sides. So over here, the derivative of natural log of y, we have 1 over y. And we have to multiply by, use the chain rule, we have to multiply by the derivative of the inside function, which will be dy dx. And over here on the right, we basically have the same thing going on. Derivative of natural log of f is 1 over f df dx, plus derivative of natural log of g is 1 over g dg dx. And if we see this y right here, I'm going to go ahead, just to make things easier, and replace that right now with what it is. We defined y to be f times g. And now to isolate the dy dx, I'm going to multiply both sides by fg. So I'll multiply this side by fg, I'll multiply this side by fg. So on the left, the fg's cancel out, and we're left with dy dx. This is equal to, and for now I'll just distribute it and I'll worry about canceling things out later. So we have fg times the first term, 1 over f df dx. And then don't forget to distribute this also to the second term. So that'll give us 1 over g dg dx. Now we can clean things up slightly. We have dy dx equals, now on the first term here, the f's cancel, and we're left with g times df dx. And in the second term, there should be, I forgot to write it down, there should be an fg in the front here. So let me put that in right here. That was just a mistake. And on the second term here, the g's will cancel out, and we'll be left with f times gd dx. And we've completed the product rule. Now I'm going to write this the way it's usually written. I'm going to switch the order of these two terms here on the right-hand side. So I'm going to write this term first. This is f times dg dx plus g times df dx. So basically what we have here is the first function times the derivative of the second function plus the second function times the derivative of the first function. And that is the product rule for derivatives.